So we're talking about rational functions here, guys. And there's some few rules for rational functions on how to find horizontal asymptotes. And, how to find vertical asymptotes. And I guess let's just start with rule number 1. Do you guys want to read that one really quick to yourselves? And then we'll talk about it in about 30 seconds or so. So question number 1, or I guess not question number 1, comment number 1. Why is that true? Why is it true that if I have a degree larger in the denominator than the numerator, and I'm just making this up, 3x squared plus 25 over 5x squared plus 3. Why is it true that my horizontal asymptote is 0? Oh. Oh, just because it says that up there, Mr. Chavez. It says that if the degree of the bottom is bigger than the degree of the top, ooh, that's a 3 there, that it's going to be 0. Yes, miss.
That's like having 0 as your numerator, like 1 as your denominator.
Well, the denominator is bigger than the numerator, right? So don't worry. It's all. Is it the safe space, guys? All right. So check it out. Let's just look at this. This example, 1 over x. Does everyone agree that in the bottom the degree of this x is 1, and in the top I don't have a coefficient x with anything, so it's like saying x is a 0 or whatever. Look what happens as x gets large. I'm approaching infinity. So 1 divided by 1, that's 1. 1 divided by 10, that's 0.1. 1 divided by 100, that's 0.01. 1 divided by 1,000, that's 0.001. So what's happening as my denominator gets larger and larger? What is the output approaching?
0.
It's approaching 0. So it really is that simple. So we're talking about rates of growth, right? As x gets larger, the denominator is growing faster than the numerator. That's all. That's all that's happening. So as the denominator gets larger and larger, look what's going on. The output is getting closer and closer to 0. You're adding more zeros to it. So that's why this is true, that your horizontal asymptote equals 0. Cool or not cool? Now check it out. Let's look at ABCD down there. Is there one where the degree of the denominator is bigger than the degree of the numerator? Yeah, what letter is that? No, A has the same degrees. Letter D? So, letter B. No, the numerator is bigger than the denominator in B. Just D. We're looking for, the denominator means down, the numerator means up. The denominator has a degree of 3, while the numerator has a degree of 2. So the denominator, letter D, has a horizontal asymptote of 0. Yeah, that's it. And let's prove it to you guys, because I want you guys to see 3x squared plus 5x plus 10. So watch. I got my calculator here. And I just got a whole bunch of stuff. Let me clear it out. Oh, I wanted that one there. What was my numerator? 3x squared plus 5x plus 10. Did I say that correct? And what was my denominator? Was it 5x cubed? Plus 25x. Sorry, I go really slow on these things. Plus what? Oh, x squared. 25x squared plus 10. Okay, check this out. I'm going to go y1 over y2, which is that fraction, right? So y1 divided by alpha trace y2. And really, you just got to pay attention to, in my table here, you just got to pay attention to y3. So look what happens. I guess let me delete everything too. All right, so look what happens. I'm going to put 0, and I have some number. So right now, y3 is at 1. I'm going to put 10. And then now y3 is at 0.04. Man, it goes down real fast. Look how the denominator is bigger than the numerator. The 75 tenths in the bottom, the 3/16 in the top. I'm going to put 20. And then enter. And then look at y3, the output. 0.02. It's even closer to 0. I'm going to go to 30. And look, the denominator is just huge now. And the numerator is growing also, but the denominator is growing way faster. The number in red is growing way faster than the number in blue. And look at the output, 0.01. Let's go to 50. Look, 0.011, so it's even closer than the previous one. Let's go to 100. Put an extra 0 there. 0.0058. Let's go to 1,000. Yeah, it's approaching 0. That 6e to the -4, that just means there's 3 zeros in front of the 6 guys. So 0.0006. So what's happening to the output? It's approaching the y value of 0, so it's converging to y equals 0, which is the definition of what a horizontal asymptote is. You might have learned this, maybe the word end behavior comes in. You might have learned it that way, maybe. Cool or not cool? Yeah, that's all it is, guys. If you spit in the ocean doesn't rise. What? No, I mean, right? You take a whole bunch of people and you tell them spit in the ocean. Like, it's not gonna just rise, rise ocean. I actually used that example to teach a kid about end behavior, and it worked. He got it down. So, no, I'm not kidding. So this is how I taught him. I'm like, what's the end behavior of the numerator? And they're like, the 3x squared. I'm like, yeah, the 5x plus 10 is like spit as x gets large. What's the end behavior of the denominator? 5x cubed. Like, yeah, the 25x squared plus 10 is like spit, only as x gets large. Like, what's my end behavior? 3x squared over 5x cubed. Perfect. What's growing faster? The bottom. Oh, okay, so what is this approaching? I guess it's approaching 0. Like, yeah, there it is. Y equals 0. I mean, that's one way to do it, maybe. But maybe not, I don't know. What'd you learn when your parents ask you what'd you learn today? What'd you learn today, guys? Oh, I learned about spitting in the ocean. All right. Read letter or comment. Read comment 2. So according to comment 2, if the degree of the numerator is bigger than the degree of the denominator, you have no horizontal asymptote. So look at letter B. Letter B, the degree of the denominator is 3, the degree of the numerator is 2. So this has no HA. HA is an abbreviation for horizontal asymptote. Why? Because you're not converging on any number, guys. So if I were to type that into my calculator, 5x cubed, 25x squared. Okay, so check it out. 5x cubed, and I guess I could have just gotten the one from down there. Oh well, too bad. Plus 25x squared. Plus what? Plus 400. I just chose random numbers there. What did I have in the bottom there? 20x squared plus what? 100? Just one? Okay. So there it is. Well, my numerator and my denominator, y1 and y2. Look what's going on to my output. So look at y3. It's just getting larger and larger. Well, I know at 0 it says 400, then it goes back down. So let's disregard that one, because obviously there's stuff going on in the middle anyways. But as x gets larger, 10, 20, 30, 50, 100, 1000, look at the output. 3, 6, 8, 13, 26, 251. It's just getting larger and larger, guys. It's not converging to anything. So if I keep adding zeros there, the output just keeps getting larger and larger. You're not getting closer to any y value. Does that make sense? Okay, so let's try to really hard not to be robots, because there's a reason why all these things are happening. So that's why letter B has no horizontal asymptote. Okay, finally, go ahead and read the third one, and then in about a minute we'll tackle it. Remember, guys, horizontal asymptote has to deal with end behavior because we're talking about what happens as x approaches infinity. So if you were that kid, what's my end behavior of the numerator? The 3x squared. What's the end behavior of the denominator? What's your ocean? The 5x squared. And look what happens. The x squares cancel each other out, and you're just going to be approaching the number 3/5. And it is true that if I were to type this into my calculator, 3x squared plus 5x plus 10. Let's see if I can remember that. Y equals, clear it, 3x squared plus 5x plus 10. And what did I have in my denominator, guys? Okay, this is going to give me a decimal. So before I continue, 3 over 5 is what decimal value? Do you guys know? 0.6. So check it out. Let's go to my table and let's see. Oh man. Okay, I know it says 0.6, but it's not. Look what happens as you get closer, as you get bigger and bigger. Now, Chavez, it says that it's exactly 0.6. It's not. If I hover over it, check it out. It's going to say 0.599999. 0.59999999, which the calculator is being lazy and is just saying, it's 0.6. So do you guys see what's happening, guys? So hopefully you're not a robot anymore. Like now you read the rules and maybe you had it in your little, what is it called, journal or what is it called when you like cut and paste stuff? There's a word for it. Something journal. Interactive notebook. I don't know. So now that you look at your interactive notebook and you read your little rules, this is why, guys. Cool? I mean, maybe you always knew this. Did you always know this? Okay, but now is it starting to, like, see, so make sure you understand the concept, because if you understand the concept, you'll never go wrong. Your memory will eventually, in the end, you know, our memory will deteriorate, I guess. I hope that it never does. I hope no one ever gets Alzheimer's, but yeah. But I think your brain shrinks as you get older. Yeah, but if you understand this concept here, not that but no, I'm just trying to say, like, okay, let me give you an example. I don't know, this didn't happen to me, but I read this and I cry for everything, guys. I'm a crybaby. And there was a patient that had Alzheimer's, and it was her mom that was talking to her. Her mom was talking to the mom, or the daughter was talking to the mom who had Alzheimer's, and she goes, "Do you know me?" And she's like, "Well, I don't remember you right now, but something in my heart tells me that I love you, and that I care for you, and that you're the one." And all that is what I'm trying to say is, like, deep down inside, she knows. She knows, like, you're my daughter. So I'm not saying trying to relate math to that, but if you really understand it, then you'll know it, like, deep down inside. All right, same thing with letter C, guys. The highest degree is 3 in the top, the highest degree is 3 in the bottom. So my horizontal asymptote is 7 over 2. Done. Cool? What's up? Slant asymptote is not the same. Letter B has a slant asymptote, but we're not going to get there today because we're not there yet. All right. Before this past year, guys. All right, guys, let's focus. Before this past year, I would give real. I mean, I'm not saying that the summer packet you guys did was not real. It was, but before that, I would give like real notes. And here's an excerpt of what I used to give. And I typed all this out myself. I still have it just in case, but I had to adjust because of the pandemic and all that. So I'm going to go ahead and go over the problem, guys, just to see if we can introduce what a hole is and the difference between a vertical asymptote and a hole. So here we go. If I have a function, and I'll try to write large, and the algebra is what's going to hurt us, guys, because we've been out of math for a while. If I have a function like that, and I told you guys to graph this function without a calculator, I would hope that you would be able to break this down, and I would hope that you would say, well, the numerator is the difference of squares, so I can write this as x plus 1, x minus 1. And on the bottom, you can't do anything about it. You just have an x minus 1. Can we do that? And then from there, I would hope that you would tell me, well, I have a factor in the top that looks like the factor in the bottom. And I can delete those two. Now, my domain is all real numbers except 1. When you're graphing this function, you're going to graph x plus 1 because that's all you have. So this equation here is y equals x plus 1, but there's one big deal. What's the big deal, Chavez? Remember that x cannot equal 1. Why not? This is my original function. You cannot divide by 0. If I plug in 1 in the bottom, you get 1 minus 1, which is 0. Do you guys see that? All right. Next, notice that I canceled out my factor. If you want to figure out where that hole is, remember, x cannot equal 1, so at 1 I have a hole. See? If you want to figure out where that y value is, plug in that 1 in here into x. What's 1 plus 1? So that hole is located at 1, comma 2. If you are looking for the technical word instead of hole, because you don't like the word hole, the technical word is called removable discontinuity. What is a hole called? Yeah. So if you want to be mean to someone, you're a removable discontinuity. Oh, that's an inside joke. Never mind. I'll stop. Okay. How do we feel? Yes, ma'am.
Okay, so do we get the whole from the fact that our end equal is x plus 1, or do we get it from because we canceled out the x minus?
We get it from a combination of two things. X equals 1 is not part of the domain. So if you're not part of the domain, I should not have a pixel there, right? And then the second fact is that I canceled out one of my common factors. So to answer your question, and I don't want to, because it's, to answer your question, if I want to give you like a cheap answer, anything that cancels out is going to be a hole. But not always. 95% of the time. And that's just a rough percentage. I can't tell, man. I can't tell, guys. With mask, I cannot tell if you guys get it or not. I'm looking at the classroom to try to observe to see if, like, do we got it? And this is what I see. I just see. And I can't tell. Like, before, you give me this look, I know you're lost. Like, okay, totally lost. But now, like, I can't tell. Like, I don't know if you're, like, focused on me. Like, you're like, I don't know if that means, like, you're like, oh, I'm in the zone. Or, like, I don't know what you're doing. I'm just looking up at you because this is the right thing to do.
I'll give you the right answer. We're not in the zone.
Oh, man.
Y'all are in the zone. Y'all can stay there. We don't know where the zone's at.
Okay, we're going to get you in there.
I don't know. That's great for y'all. But very happy to.
Have you ever told a joke to, or has someone ever told a joke to you and you didn't hear the joke, but they stopped saying it and then they laugh and you're like, ha ha ha. Or sometimes you're like, all right, tell me again. And then they'll say it again, la la la, and then you still didn't hear it. But they start laughing and you're too scared to ask a third time, like, I'm not going to ask them anymore, just laugh. Oh, ha ha ha, so funny. That's how I sometimes feel, like, do we get it? Like, yeah, I got it. And then you go to your buddy and like, hey, what are you talking about? Like, hey, you just told me like you got it, you know? Like, let's try to avoid those type of scenarios, guys. All right, so maybe with practice, we'll figure this out, guys. So here we go. We're going to ask a whole bunch of questions. So let's ask a whole bunch of questions on this, guys. I know this says give the coordinate of the x-intercept, but let's go ahead and write a whole bunch of stuff. I want x-intercept. I want y-intercept. I want, let's see, what do I want? Do I have any holes? Yeah. I want the horizontal asymptote. Bless you. And I want, finally, the, bless you. So there we go. We got a whole bunch of things. So let's do the obvious one first. Yeah, because we just learned that. So the obvious one first is a horizontal asymptote. I look for the ocean in the numerator and the ocean in the denominator. I see an x squared and an x squared, so I'm focusing on those two only. So my horizontal asymptote is, yep, y equals 1. Does everyone see how we got that? All right. Next, what do I think is easiest? All right, let's factor everything out. So we're going to have to practice factoring. What two numbers can I multiply to give me 27 that adds up to a 12?
9 and 3.
So we're going to write x plus 9, x plus 3. In the bottom, what two numbers gives you 12 that adds up to 7? 3 and 4.
No, they don't. 6 and 6.
Yeah, 1 and 6.
Plus 1 and 7. Yeah, but 6.
We're good, guys. We're good. All right, here we go. You guys ready? So the first thing I'm going to do now that I got it looking like this, I'm going to look for factors that cancel. Do I have a factor that cancels? Because x plus 3 cancels, I know that I have a whole.
Is that negative 3?
A negative 3.
Oh, what?
The factor that cancels, what makes that factor 0? A negative 3 plus 3. In case you're wondering, like Chavez, I'm confused now. The domain?
Not the domain, but the
Well,
X-Intercepts when it says a parabola and then it's 0. Yeah. It's like that for finding a hole. Yeah. So you just say the equation x plus 3.
okay, my domain is all real numbers except negative 3 and negative 4. Why? Because we cannot divide by 0. And negative 3 would make the denominator 0, and negative 4 would make the denominator 0, with, if I keep, that factor. Does that make sense, guys? Okay. So my domain is all real numbers, but negative 3 and negative 4. Cool? Well, not for a whole. We'll talk about what negative 4 is. Negative 4 is something. We're going to find out right now. All right. So I have a whole. Don't worry, I'm going to answer your questions. I have a whole at x equals negative 3, and let me write some good notes here. I'm going to write because we have, or I guess because f of x has the same factors in numerator and denominator. Yeah. But that only works 95% of the time. And that's just a rough guess. That's just a rough number. It works the majority of the time. All right, what was your question, miss?
Why is it negative 3 and
Oh, the domain?
Yeah.
The domain is all real numbers except this. So you see that little equal sign with a slash? So it can't be negative 3, negative 4, because if I plug a negative 3 in for x value, you get a 0 in the bottom. And you can't divide by 0. If I plug a negative 4 in right there, negative 4 plus 4 is a 0, and you cannot divide by 0. It's in the bottom, so that means like some number divided by 0, and you can't. If you ever figure out a way how to divide by 0, you will win the Nobel Prize. Yes.
Okay. So like the reason I'm confused is because like the way they explained it earlier, you were saying like you can't divide by 0.
Correct.
But if you have like a negative 4,
That's going to give me a 0 in the bottom, right?
the 0 is going to become the bottom is going to become 0.
Hmm?
But that wasn't the original. It was just something that we factored out. So that's why I don't think
Yeah, it's not at negative 4. It's not a whole, but it is something. We're going to talk right now.
because it can't be a hole if it doesn't cross out within the
Correct. All right. So now, since everyone's focused on the 4, we're going to talk about that right now. You guys ready? We already know that negative 4 is not part of my domain. If it's not a whole, then what do you think it is?
Oh, asymptote.
It's a vertical asymptote. So x equals negative 4 is a vertical asymptote. You cannot cross vertical asymptotes. Horizontal asymptotes you can, but not vertical. Yeah, if your teacher told you that you can't cross, your teacher was wrong. High school teachers, that's what high school teachers do all the time. Well, you be nice to her. Don't tell. She just got out of college, so and maybe she didn't take like So you can cross horizontal asymptotes, guys. You can't cross vertical asymptotes. You can cross horizontal.
Wait, why is it? Why is it a what?
Why is it a what?
Why is it a vertical?
Oh, because you can't divide by 0. So remember, so you can't cross. So x cannot equal that -4. So you can't, as x gets closer and closer to -4, you'll never touch that vertical line because it's an infinite discontinuity. Does that make sense, guys? Okay. So for those, I'm not going to say the word haters, but let's say, so those that were like, what? You cannot cross horizontal asymptotes? So look, you see that red dotted line there? I'm going to call that a horizontal asymptote. What if I have a signal that does this and it just keeps going back and forth? By definition, is that a horizontal asymptote? Yeah, it's converging at that dotted line, but I crossed it many times. So you can cross a horizontal asymptote many times depending on the model that you have.
So, okay, so it depends on the, like, it's like an exponential function. It's not gonna
Yeah, if you have a rational function, it's not going to cross a horizontal asymptote. But if you have, well, it depends. Some rational functions do cross it. In the middle, they do cross it. Okay, next question, guys. So we already got our vertical asymptote, x equals -4. So let's open your mind some more. The easiest one to get is the y-intercept, because all you got to do is plug in what for x? 0. 0 plus 0 plus 27, 0 plus 0 plus 12. So my y-intercept is 0 comma 27 over 12, which, does that reduce? 2.25. 8, 9, 9/4. Same thing. Yeah, 3 goes into 27 9 times, and 3 goes into 12 4 times. How do we feel, guys? All right, x-intercept. Oh. Okay, tell me. I can't read minds, miss, especially with the mask.
No, I'm good.
Okay.
Hanging in there.
Okay, so we're good. Alpha team? Okay, we just need more practice, that's all. X-intercept. All right, the whole concept behind the x-intercept, remember, guys, is where you cross the x-axis. Remember what the y value is when you cross the x-axis. What's the y value there? Oh, man. When you cross the x-axis, the y value is 0. Yeah, the y value is 0, guys. So what am I trying to say? I'm trying to say that just set this equation equal to 0. So 0 equals x squared plus 12x plus 27. And I guess let's go ahead and write the denominator. Oh yeah, I would have done that one. But it's the same thing. But yes, I'm going to focus on the factored form. So maybe I should have written that one. Are we okay so far, guys? All right, so let's focus on this one here. All right. I already canceled my x plus 3's, and the only way to get a 0 as an output is if I have 0 divided by any number. Does that make sense to you guys? So then all I got to do is focus my attention on the x plus 9. What will make the x plus 9 0? -9. So my x-intercept is -9, 0. That's it. Yay or nay? Okay, I'm going to give you guys a trick question and see if we can figure it out. No? Okay, let's do some more practice.
You know what? We can do some cognitive thinking or whatever.
Let's do some more practice, guys. So on this one, I want the same thing again, guys. I want my horizontal asymptote. I want my vertical asymptote. I want my x-intercepts. I want my y-intercepts. What else do we say? Does it have any holes? And is that it? Yeah. Horizontal asymptote. Or I guess which one's the easiest one? Vertical asymptote. Does anything cancel out?
No.
Nothing cancels out. So where do I have vertical asymptotes? When the denominator is 0, right?
Yes.
So the denominator is 0 if x equals -2, and -5. Those are my VAs. Are we okay? All right. What is easiest to get now? Are there any wholes? Nope. There are no factors that cancel out. Let's see. What else? Should we do the y-intercept? Okay, plug in a what for x? 0. So 6 times 4 times 8 over 2 times 5. What's that? 2, 6 times 2, 12. 12 times 8, 50. 12, 10, 8. What is it? All right, let's do it. What did I get? 6 times 2 times 8. 6 times 2 times 8. 96 over 5. Yes. I said 2 goes into 4 twice. We didn't have to. You could have just gone. All right, so sorry if I confused you guys. 6 times 4 times 8 over 2 times 5. So here's my little calculator. I'm going to go 6 times 4 times 8. Enter, and I'm going to divide that by 2 times 5, right? Which is 10. And I get a number like that. And if I want to turn it into a fraction, 96 over 5. Yeah, I said 2 goes into 4 twice. And then... Are we okay, guys? Okay. X-intercepts. All right, guys, focus. X-intercepts. So that means where your y value is 0. So 0 equals, I can just focus on the numerator. 6 parentheses x plus 4, 8 minus x. You can just focus on the numerator because nothing factored out anyways, or canceled out. So where does this equal 0 at? 8 and -4, correct. So my x-intercepts are -4, 0, and 8, 0. And then finally, the last one, horizontal asymptote. So we need to figure out our ocean. You do not need to distribute all of it. You can just go 6 times x times -x. What's that? Positive or negative? Negative 6x squared over, what is x times x? All I'm doing is figuring out the biggest degree. You could FOIL both of them out if you want. So my horizontal asymptote is y equals -6. We're okay, guys? Ask. All right, let's do another one. This one wants holes, so it's definitely gonna have a hole on this one. So I'm gonna say I want my holes, I want my vertical asymptotes, I want my horizontal asymptotes, I want my x-intercept, I want my y-intercept. Before you do anything on this one, guys, I would make life simpler. You don't want to deal with a negative x squared minus 4x plus 32. Factor out a negative. Now that you factored out the negative, it becomes much simpler, guys. Chavez, what? What two numbers, when you multiply, give you negative 32, but add up to a positive 4? What two numbers in the bottom? Multiply to give you positive 24, but add up to 11. Does this function have a hole? Yes. That's right. You have a hole at -8. If you want to figure out what the y value is, you plug in a -8 into what you have left. I'll just leave it like that for now. Do I have a vertical asymptote? I do. Where at?
-8 and -3.
No, one of them, not both.
-3.
-3.
Oh my god. Oh wait, because that one's a hole.
The other one's a hole.
Wait, where?
Do I have a horizontal asymptote?
-1.
How'd you get that?
Because it's exponents the same, so it's -1/1.
Yeah, so she said the degrees are the same. So she's following one of the rules from the one. So -1 divided by 1. So horizontal asymptote of y equals -1. X, and I'll slow down. X-Intercept. We focus on the numerator for that one. And where do I have an X-Intercept? No, we already canceled that one out. Just 4. 4, 0. If I plug in a 4 for X, I'll get a 0 there, guys. Are we okay? Did we have anyone with? Y-intercept. Plug in a what into your X's? 0. So you get 32 over 24.
Oh yeah, okay.
Which reduces to positive 4/3.
Wait, so can I just do, because what I did is I left that, like, the thing that we had to x minus 4, negative x minus 4, negative and the parentheses x minus 4, and then I just plugged in 0 for that.
Yeah, that's fine.
Plus 4 equals 3.
Yeah, that'll work.
I did the same thing.
How do we feel, guys?
That one was good. That one was a little bit slow.
Ask. What's up?
So if you look at the 12 and the last one, when you take out the holes, you get x, like, this one is x minus 4 over x plus 3.
With a negative on the outside, right?
Yeah, with the negative, so then would it always be that the numbers in the parentheses are your y-intercept plus 4, 3 is our y-intercept itself?
The 32 over 24 would have reduced to 4/3. But yeah, you can just use the factors that you have left and you'll get the same value. I don't know.
You went math.
I don't see any tissues, miss. Do we have a box anywhere of tissues? Oh, there it is. What's up, Estala? For the whole, is it what? No, there's a y value somewhere. All right, let's talk about that. All right, guys, real quick. The one in green, the ordered pair in green. If I want the location of that hole, how do I get it? I want this y value. Into what you have left. So -8 here, -8 there. -8 minus 4, what's that? -12 times a negative, so positive. And then on the bottom divided by a -5. So -12 over 5. It's negative.
Why would it be negative?
I have a negative out here.
On the outside.
The numerator turns positive when you do negative times the negative, but the denominator is a negative. Do you see it, Lopez? Or? Okay. Do you guys want to see this question graph?
Wait, but I have a question.
Yeah, ask. Please.
Okay, so that negative over there, wouldn't it make it more positive?
Are you talking about the X-intercept?
No.
Uh,
The negative 8, wouldn't it be plus 4?
I would leave the negative on the outside. Negative 8 minus 4 is negative 12. Negative times a negative is a positive. I mean, unless you really want to distribute, but then that x turns negative, right? Okay, you have this, miss. I don't know what you're trying to do. You have x minus 4. And all I'm doing is plugging in a negative 8 in there for x. But if you want to distribute it, which I think is what you were trying to tell me, then it would be a negative x plus 4. And then I would be plugging a negative 8 into that. So you get the same thing. That would be positive 12 now. No, you're good. You're good. All right. Any other questions, guys? All right. You guys want to see this graphed? No? Okay. No, yeah, let's. We don't have to. No, you're good. You're good. Let's go to the next question, guys. So here we go. We're going to get the same values again. Holes, vertical asymptote, horizontal asymptote, x-intercept, y-intercept. So let's first find the horizontal asymptote. Actually, on this one, they don't want that. They want us to find... Oh, check it out. We got one that it crosses the horizontal asymptote. So here's a rational function that crosses it. So before we continue, do we know how to find the horizontal asymptote first?
Yeah.
What is it? 1/5. Yes. So my horizontal asymptote is y equals 1/5. Now, if I cross that line, then that means this function, if I want to find my x-coordinate where it crosses it, this function must equal what? Yeah, you said it right. What does it equal? Yeah, 1/5. Hmm? So my apologies if you've had teachers in the past tell you that you can't cross horizontal asymptotes. You can. They just, I don't know. So now, since we're trying to find the x-coordinate, what do we do now? You can just cross multiply. You've been doing that since like 6th grade probably, right? So here we go. We're just going to cross multiply, guys. So we're going to have 5x squared plus 15x plus, what's that, 40? Equals, and I'm just going to multiply by 1 again, so 5x squared plus 9x plus 9. So here we go, guys. In order for this to work where it's easy, your quadratics should always cancel, the 5x squares, and they always will if you cross the horizontal asymptote. So here they are, they cancel out. It's like minus 5x squared minus 5x squared. So now I have an expression, 15x plus 40 equals 9x plus 9. And all you're trying to do is solve for the x coordinate. So I'm going to get all the x's to one side, all the numbers to the other side. Minus 9x minus 9x. So 15 minus 9, what's that? So 6x, and I'm going to move the 40 to the other side. Minus 40 minus 40. So 6x equals positive 9 minus 40. So now to get the x by itself, I'm going to divide by 6. So where does this happen? At negative 31 over 6. If you wanted an ordered pair, you would write negative 31 over 6, comma, what's your y value? Oh, I heard someone say it. Yeah. Are we okay? Okay. No, we're good, guys. All right.
Okay, that makes sense now.
Yeah, if you just have an expression, any expression can equal any expression. All right, are we doing okay, guys? Don't worry, we're almost done. So I want to figure out this line here. This is obviously a rational function because I see a vertical asymptote. So I have a vertical asymptote at x equals 0. So let that give you the hint. They want you to figure out the equation. So if I have a vertical asymptote at x equals 0, I know for a fact that I have to have an x in the bottom. Like, right? Okay. Next, I see a hole, and that hole is located at -1, -1. In order for me to have a hole, I have to have the same factor. Notice that I have a -1 there. No, the opposite. X. So you have an x plus 1 in the top and an x plus 1 in the bottom. Cool or not cool? Yeah, actually that's pretty much it. Sometimes we have the letter A, but for the most part they're going to make it all pretty straightforward. So that's it, guys. That's your equation. How do we feel? No, this one's coming from UH, and all the questions are going to be pretty basic. Well, go ahead. We got practice first, and then we got a UH. So we don't assign the UH until we've covered all of them. All right, last one here, guys, and then we'll set you guys loose. Determine each feature of the graph given the function and draw a sketch. I don't think that's too hard to do. I think we can draw a sketch in a little bit. Horizontal asymptote, what is it? 1/2. 2/4, but that reduces to 1/2. Can we do that? Yes. Nothing cancels out. So I'm going to find my vertical asymptote. I do that by setting the denominator equal to what? 0. So 4x minus 9 equals 0. I'm going to solve for that. 4x equals 9. Divide by 4. Divide by 4. X equals 9/4, which is approximately 2.25. Well, it's not approximate. It's equal to 2.25. Yes. I think I'll take both. X-intercept. What do I do to find the x-intercept? Make the numerator equal to 0. Is that what you said? Perfect. Solve for that. So again, 2x equals -9. Divide by 2. Divide by 2. X equals -9/2. So my x-intercept is -9/2, comma 0, or -4.5. Are we okay, guys? Y-intercept, plug in a 1 in for 0. I'm sorry, plug in a 1 in for x. 0. So you're going to get what? Yeah. You're just plugging in a 0 in there. And then finally, do you have any holes on this one? No. All right, can we draw a sketch? I think we can. Here's our sketch. I mean, this is what we should have done like a whole bunch of in Algebra 2. But maybe last year was hard to do. Horizontal asymptote of 1/2. So here is my horizontal asymptote of 1/2, not drawn to scale. Man. So there's my 1/2. Vertical asymptote of 9/4. So what's that? 2.25. So I'm going to say 2.25 is like right there. This is x equals 9/4. This is y equals 1/2. When you do delta, it's going to want x equals, y equals when it wants horizontal and vertical asymptotes. Let's see what else. I have no holes. I have a y-intercept of 0, -1. So 0, -1 point. I have, what else do I have? An x-intercept of -4.50, so somewhere over here. And that's pretty much all you need. So it's going to look something like this. Goes like this. And you can't cross vertical asymptotes. That one looks like that. How do we feel, guys? All right, so your assignment, you just have one of two deltas to take care of. Delta 3a is the easier one. The first one that you see is the easier one. And then the harder one is the B one. So log into delta. I don't think I've cleared it, so let me clear it real quick. can't. The delta tomorrow, but you can get it done today, I think,